Hello and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of solving scale problems. This is standard 7.5C in the great state of Texas, and we are using item number 42 off the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So we've got two parallelograms that are similar. Now that's going to be very important for us because that actually gives us a clue. So similar means we've got the same shape. So these are two parallelograms. You can't have a rectangle be similar with a triangle. So you have the exact same shape that it's scaled out differently, and you've got the same angles. And so the only difference are the side lengths, but they're proportional. You see how you've got a little angle symbol right there? It means you can kind of match those two up. So you can tell that one looks to be just a larger zoomed out version of the other. That's what similar means. So we need to find the length of this right here, PQ. And we actually have all the information we need. We are going to make a proportion, but there's actually two different ways that we can make a proportion, and you'll see that both work because they're both going to ask us to do the exact same math. So first, let's just call this the small one, and let's call this the big one. Let me show you how you can make a proportion like within the small one. So let's say we want to make a proportion of this side. So that's going to be our small, right? 12. And we're going to relate it to the other small that we know of, this 16. So this proportion works if, since I'm going small to small, then this other one needs to be big to big, but we need to match our sides. So take a look at this 12. This 12 is this side right here on the left that's kind of slanting up, so we need to find the corresponding side on this side and match it up. So since they're oriented the same way, that makes it super easy. Sometimes they'll kind of rotate it and you have to mentally rotate it back to make it work, but this is pretty easy. That 12 matches up with that 30 because those are both oriented in the same direction, and they both have this same angle, right? They're both this left side off the same angle. So that's going to be 30. So that 12 matches up with that 30, and then the 16, which is the base of our parallelogram, which is on the other side of this angle, that matches up with what we're looking for, PQ. So that's one way that we can do it. The other way that we can do it is we can do small to big. So let's see what that looks like. So we can go ahead and take this, what we just did, this 12, and match it up with its corresponding side on the big. So we can do 12 to 30. And then we can do the same thing. We have to match small to big. So we're going to take this 16. We're going to match it up with its corresponding side on the big. That's going to end up being 16 over PQ. Once again, we're looking for PQ. And you might be thinking, well, how could both of them work? Well, remember, we use cross multiplication because since these are proportional, we know that this 12PQ, PQ is our unknown, equals 16 times 30. We'll have to figure that out. And then divide. Look what we have right here. 12PQ, right? They still ended up across from each other, equals, this one's slightly different. It's 30 times 16, but look, that's the commutative property. That's it. It's the same thing. So let's figure out what is 30 times 16. That's 0, that's 18, that's 30. All right, so 480. So I've got 12 times PQ equals 480. Divide both sides by 12, we get our PQ. So 480 divided by 12, that goes in there 4 times, 48. Have to bring that down, make sure we get that 0, and we're good. So our answer here is going to be F 40 inches.